Section 5.3, inverse functions. We're going to do a little algebra review about inverse functions, and then we'll do a little calculus. What do you know about inverse functions? Anything? What do you mean by opposite? Yeah, opposite's not quite the right word, right? Because the opposite of 2x is negative 2x. Opposite means a minus sign, but that's not the inverse. So what's inverse? What do you mean flipped? Reciprocal is not quite right either. Because reciprocal is 2x and then 1 over 2x. Those are reciprocals, but they're not inverses.
Negative.
Negative reciprocals? That's a property of perpendicular lines in the slope. What did you... I forgot what you said. What do you mean by flipped? Or did you mean reciprocals also?
Yeah, I guess so.
Yeah, that's not quite right.
The x values are mapped to where the y values are and vice versa.
Right. What inverses do is they interchange the x values and the y values. Okay, so the formal definition is f of x and g of x are inverses if two things have to happen. F composed with g of x has to be x, and g composed with f of x also has to be x. So basically, what do f and g do to each other? They cancel each other out. Notice we had f composed with g. The f and the g cancel each other out. We're just left with the x. The g and the f cancel each other out. We're just left with the x. All right, so example. F of x is 3x minus 5. Can somebody give me a guess as to what the inverse of 3x minus 5 is? It's okay if you're wrong.
X minus 5 over 3.
X minus 5 over 3.
X plus 5.
X plus 5 over 3. That's a better guess. Are those two functions inverses? Well, to see if they're inverses, what we have to do is we have to compute f of g of x. And what does that symbol mean to do again?
Where you have an x and f, you put the entire g.
Right. You take the f function, wherever there's an x, you plug in the entire g function. So we would have 3 times, I plug in the x plus 5 over 3 minus 5. I simplify that. When I simplify, I get x. Because I can reduce to 3's. X plus 5 minus 5, that's x. So are they inverses? Maybe. Why do I say maybe? It's got to work the other way too. You've got to be able to switch the order. Sometimes when you do function composition, when you do f composed with g and then you do g composed with f, sometimes you get different answers. In fact, most of the time you get different answers. It's pretty rare that you get the same answer. G of f of x is, this time I take the f of x function and I plug it into the g. So I'm going to have 3x minus 5 plus 5 all over 3. Once again, I simplify, the 5's reduce, the 3's reduce, I'm left with x. So those are inverses. Now I'm convinced that those are inverses. And what I want you to notice is, I said a minute ago that what inverses do is they interchange the x values and the y values. So I'm going to take and plug a few x numbers into my f of x function. I picked 3 numbers that I like a lot. I like 0, 2, and negative 2. What do I get when I plug 0 into my f function? Negative 5. And then when I plug in 2, 1. And when I plug in negative 2, negative 11. All right, now I'm going to take 3 numbers that I like an awful lot, and I'm going to plug them into the g function. The 3 numbers that I like an awful lot are negative 5, 1, and negative 11. If you were picking 3 numbers at random, those probably wouldn't be the first 3 you pick. But why did I pick those?
Because there's a Y value.
There are the y values there. And notice what happens when I plug in -5 here. I get 0. I get the x value that I started with over there. When I plug in 1 here, I get 1 plus 5 is 6. 6 over 3 is 2. And I won't work it out. I think you're convinced at this point. When I plug in -11, I'm going to get -2. Questions on that?
What's this used for?
Oh, we're getting there. We're getting close. A little more algebra to do, and then we'll do some calculus. What's this used for? Example number 2. F of x is x squared. Any guesses on the inverse of the function x squared?
Square root x.
Square root of x seems like the obvious answer, right? X squared and square root of x cancel each other out. Well, let's see if that's true. F of g of x would be, I take the square root and I plug it into the square. So I'm going to have square root of x squared. So what happens when I take something, I square root it, and then I square it? What do I get?
X.
X. I get right back what I started? All right. So are they inverses?
No. No. X doesn't, so squared doesn't have an inverse.
X squared doesn't have an inverse. Why not?
Because a function can't have 2 y values, so,
You're absolutely correct. And here's where the problem comes in. What happens when I do g of f of x? I would take x squared and plug it into my square root function. And most people would say, well, those two things cancel out when you get x. But I say they don't. Correct. So I'm going to pick a number that I like a lot. I'm going to pick the number -3. So if x is the number -3, what happens when I plug -3 in? What's -3 squared?
9.
9. What's the square root of 9?
3.
3. Did I get -3 back? No. What did I get? +3. So when I plugged in -3, I ended up with a positive number. What happens if I pick a positive number and plug it in, like 5? I get 5 back, don't I? All right, so what's that function? If I put in a positive number, I get the same positive number back. But if I plug in a negative number, I get the positive answer. That's the absolute value function. So there's an example of where you switch, when you switch order on composition, you don't always get the same answer. All right, so that was a trick question. Almost everybody will say the inverse of x squared is the square root of x. But it doesn't work. And the problem is f of x equals x squared does not have an inverse. It was a trick question right from the beginning. And the reason x squared does not have an inverse is because it's something that's not what we call one-to-one. If I draw x squared, it looks like this. And the issue with x squared is if I draw a horizontal line, like right about there, how many times will that horizontal line hit that graph? Twice. So this might be the point 2, 4, and this might be the point -2, 4. So what would happen if I tried to, for x squared, make my f of x table and then make my g of x table? Well, my f of x table for f of x equals x squared, my f of x table would have to have 2, 4, and -2, 4. So what would have to happen for my inverse table? I'd have x would, if x is 4, y would be 2, or if x was 4, y would be -2. And now we have a problem. For this to be a function, can the x values repeat? No, so this is not a function. All right, so x squared cannot have an inverse because when you switch the x values and y values, you don't get a function. All right, so a few definitions. A function is called one-to-one if no y value repeats. Our definition of function from back in algebra was that no x value can repeat. So for a function to be one-to-one, not only can no x value repeat, but no y value can repeat. And then a fact that we just kind of proved, a function has an inverse if and only if it is one-to-one. Questions about that? All right, so if you want to talk about this function f of x equals x squared, and you want to talk about its inverse, what you need to do is you need to limit the domain. You need to limit the domain so that that function actually is one-to-one. How can I limit the domain to make it so that no y value repeats?
Use natural log.
No. I only want to use part of the graph is what I'm saying.
All the positives or all the negatives?
Typically, we would pick the positives. You could pick just the negatives and you would still have a one-to-one function. Usually we want the positive numbers, like positives, I suppose. So if f of x equals x squared, but I only choose the right-hand side of that parabola, is that function now one-to-one? Yeah, because if I draw a horizontal line, it's only going to hit once. So for that function, its inverse is the square root of x. Now I don't have that issue with negative values anymore. Questions on that? All right, so that's your brief algebra review. Now we're going to do some calculus. If g of x is the inverse of f of x, then g prime of x is 1 over f prime at g of x. All right, so here's an example. Let f of x equal the cube root of x plus 1. Is that function one-to-one? Yes, why?
Because I know what it looks like.
And what does it look like?
I'm thinking of x cubed, but I would assume it's just the other way around.
It looks like x cubed, but the other way around?
Yeah.
You're right. This graph goes through the point 0, 1. It looks like an x cubed function turned on its side.
Yeah.
Okay, so that function is one-to-one. But there's a better way to show a function's one-to-one. Anybody know a better way? What's the derivative of this function? 1/3 x to the negative 2/3, which is 1 over 3x to the 2/3. So how does that convince me that that function is 1-to-1? You could ask yourself, are there any critical points? Because critical points are where turning points happen. So where it would go from increasing to decreasing, it would go up and then down, or down and up. What can you tell me about this derivative? There's one critical point, actually. 0 is a critical point because it does make the bottom 0. But what happens if I plug in a positive number? What kind of answer do I get? If I plug in a positive number into this derivative, I get a positive answer. What happens if I plug a negative number into that derivative? I get a positive answer because of this little 2 right here tells me that I'm going to be squaring things. So if I plug in -1, I'm going to take -1 and square it, which is +1. Then I do a cube root, which is still +1, and then I multiply by 3. So this function does have a critical point at 0, but that critical point is neither a minimum nor a maximum, is it? Because the derivative is otherwise always positive. So this function is always increasing. If a function is always increasing, it doesn't have any turning points, which means it has to be 1-to-1. All right, so this function is 1-to-1. I think we beat that to death. If it's 1-to-1, it must have an inverse. What's its inverse?
Cubed plus 1?
X cubed plus 1? Maybe? Do you have a different answer? X cubed minus 1? I don't think that's right either.
What is it? It'd be -1.
X minus 1 cubed?
Getting closer. Yeah, I think x minus 1 cubed. What you do to find the inverse is you write y equals cube root of x plus 1. And then what do inverses do? They switch x and the y. So I'm just going to switch the x and the y. I'm going to write x equals cube root of y plus 1. And then I'm going to get that y all by itself. And once I have that y all by itself, that will be the inverse. So I have to subtract 1 on both sides. X minus 1 equals cube root of y. And then I would cube both sides. So the inverse happens to be x minus 1 cubed. Okay, so now I want to test this theorem with those two functions. F of x is cube root. F of x is cube root of x plus 1. And g of x is x minus 1 cubed. All right, so according to that theorem that I had there, g prime of x should be equal to 1 over f prime at g of x. Let's see if that works. Well, let's do the easy thing first. The easy thing is, let's find g prime at x. Since I have a formula for g prime, I can go ahead and take its derivative. What's g prime at x? 3 times x minus 1 squared times the derivative of the inside, but that's 1. So that was easy. All right, now let's try the other side. 1 over f prime at g of x. And if everything worked out right, we should get exactly the same answer. All right, I'm going to come over here and find f prime at x first. F prime at x was 1/3 x to the negative 2/3, which is 1 over 3x to the 2/3. So I'm going to have 1 over 3 times x minus 1 cubed to the 2/3. Does that equal 3 times x minus 1 squared? Yes, because I would flip and multiply that fraction, so that's going to be 3 times x minus 1 cubed to the 2/3. Well, what happens when you have a power followed by another power?
Multiply.
You multiply them, so that's 3 times x minus 1 squared. Questions on that? All right, well, that doesn't seem particularly useful until I give you a problem like this. F of x is x cubed plus 3x squared. No, just 3x. No, 3x squared. X cubed plus 3x minus 1. And I want you to find g prime at 3. What's g?
The inverse.
G is the inverse. Okay, so this function f of x that I gave you, does it have an inverse? Yes, how come? Otherwise it'd be a real easy problem. Why does it have to have an inverse?
Always increasing.
Because it's always increasing. If I take the derivative, f prime of x is 3x squared plus 3, which is always positive. That function is always increasing. There's no turning points at all. So it has to be 1-to-1 since it's always increasing. Can I do the same trick I did on the last problem? If I write y equals x cubed plus 3x minus 1, and then I switch the x and the y, x equals y cubed plus 3y minus 1. Can I take that equation and get y all by itself? No. Can it be done? Yes, it can be done. Do I know how to do it? No, I don't. I don't know how to get y all by itself up for that equation. I know it can be done because I know there's a cubic formula, just like I know there's a quadratic formula. But I don't know what the cubic formula is. It's big and long and ugly, and I don't want to deal with it. Anyway, using this theorem back up here, however, we can still find the derivative. All right, so g prime at 3, even though we can't find the inverse, we can still find its derivative. G prime at 3 is going to be 1 over f prime at g of 3. Can I find f prime? Yeah, I already did, didn't I? I already found f prime. Here's the hard part. I need to know what g of 3 is.
Well,
It should be f of 3, right?
No, it shouldn't
no,
be f of
it'd
3.
be the y value.
All right,
F of 3,
so
right?
correct. So g of 3, this means I'm giving you the x value for g to be 3, and we need to know the y value, which on f of x, remember f of x switches things, so that means I'm giving you the y value for f of x is the number 3, and you need to tell me the x value. So I need x cubed plus 3x minus 1 equals 3. I need to solve that equation. And I can only think of 2 ways that you could solve that equation. Number 1, well, actually I can think of 3 ways. Number 1, look up that cubic formula that I don't know and use the cubic formula. That's probably the worst way. Number 2, guess. Pick some numbers for x and hope you come up with the right answer. And number 3, use your calculator. Type this side in as y1, type that side in as y2, and find where they cross. I'm going to guess and pick the right answer. I'm going to guess x equals 1. Is that x equal 1 the right answer?
Yeah.
Yes, because if I plug 1 in, I get 1 plus 3 minus 1. That equals 3. How did I guess x equals 1 so quickly?
You know the answer to the problem.
Because I made up the problem. So when I made up the problem, when I picked this number 3, to get this number 3, what I did is I took my original function and I plugged in the number 1. That's how I got the number 3. I cheated. It wasn't a guess at all. I knew the answer right from the beginning. What you would probably do is you would probably use your calculator. All right, so anyway, that tells me that this is 1 over f prime at 1. I already have my derivative. My derivative is 3x squared plus 3. I plug 1 into that. That's 1 over 3 times 1 plus 3. So the answer is the derivative is 1/6. So even though I cannot find the inverse easily, I can still find its derivative.
And if we have its derivative, can we find it using integration?
Depends on the function,
Yeah,
sometimes.
that this function.
No, I don't think so.
Okay.
Other questions?